Alright, so in this video I'm going to review with you, the sequences and series test. So let's go ahead and get started. For the first one, we have that each time we are adding 4. So if you look here, plus 4, plus 4. So this is an arithmetic sequence where your common difference is equal to 4. For the next one, you're actually multiplying by 2 each time. So this is a geometric sequence, and the ratio, the common ratio, since this is geometric, is going to be 2. For the next one, you're subtracting 2. So again, this is arithmetic with a common difference equal to -2. For the next one, you're just multiplying by -1 each time. So that's going to be a geometric sequence with a common ratio of -1. Then for the next one, you're dividing by 5. So when you're dividing by 5, that is geometric, but your common ratio is actually going to be the fraction 1/5, that you're multiplying by 1/5, which is the same as dividing by 5. And the last one, you are multiplying by -3 each time. So again, geometric with a common ratio equal to -3. Alright, let's go ahead and move on. Classify the sequence, determine the 10th term, write an explicit and recursive rule for the sequence. So the type of sequence here, this is going to be a geometric sequence. Again, you have to identify the first term. So in this case, the first term is 15. Your common ratio is multiplying by 2 each time. So that makes it a geometric sequence. Easiest thing is to go ahead and write the explicit rule next. So a sub n equals the first term, which is 15, times the common ratio of 2 to the n minus 1 power. Then you're going to want to write the recursive rule. And for this one, you're going to multiply by 2 each time. So you take the term before, which is a sub n minus 1, and you're going to multiply it by 2. So then to determine the 10th term, you're going to do a sub 10, use the explicit formula, equals 15 times 2 to the 10 minus 1, which is 9. So when you simplify that and put it in your calculator, you're going to get 7,680. For the next one, you are actually subtracting 20 each time, minus 20. So that means that your common difference is minus 20. And a sub 1, the first term, is equal to 10. Okay, so again, this is an arithmetic sequence. Let's write the explicit rule. It's going to be a sub n equals a sub 1, which is 10, plus n minus 1 times the common difference of -20. Now you could go ahead and simplify that to 10 plus 20 is 30. 30 minus 20n. So you could do that. Oops, 20n. But you could also leave it in the other form. But if it says to simplify, you're going to want to distribute this 20 to the n and minus 1 and then combine like terms of 10 and 20 to give you 30. Recursive rule is going to take the term before, which is a sub n minus 1, and you are going to subtract 20. So for the 10th term, you're going to use the explicit rule. A sub 10 equals 30 minus 20 times 10. And then simplify that, and you get -170. Okay, so for number 9, for this one, we're going to add 100 each time. So that means that is your common difference. And then a sub 1, the first term, is 100. So your explicit rule, since this is arithmetic, let me classify this as arithmetic, is a sub n equals the first term, 100, plus n minus 1 times the common difference of 100. Okay? Recursive rule is to take the previous term, which is a sub n minus 1, and add 100. My 16th term, I'm going to again just substitute 16 in here. So a sub n equals 100 plus 16 minus 1, which is 15, times 100. And now I'm going to simplify that, and I'm going to get 1,600. For the last one, I'm multiplying by negative 1/3 each time, because I'm basically dividing by 3, which is multiplying by 1/3, and then since it goes from positive to negative to positive to negative, I know it's a negative 1/3. So that means that this is a geometric pattern where a sub 1 equals 45, and your common ratio is negative 1/3. So that's what you're going to use in the explicit rule. So a sub n equals the first term, 45, times negative 1/3 to the n minus 1 power. That means your 16th term is a sub 16, 45 times negative 1/3 raised to the 16 minus 1 power. And when you simplify that, you're going to get, you can just write it in scientific notation, negative 3.136 times 10 to the negative 6th power. It's going to be a very small decimal. Your recursive rule is to take the previous term, n minus 1, and multiply by negative 1/3. So times negative 1/3. Okay? For number 11, again, this is another geometric sequence. Explicit rule, well, first I need to identify a sub 1 and my common ratio since it's geometric. A sub 1 is 1800. And each time you are dividing by 2, which is the same as multiplying by 1/2. So your common ratio is 1/2. So your explicit rule is a sub n equals 1800 times 1/2 to the n minus 1 power. To find the 19th term, I'm going to plug in 19 for n. So 1/2 to the 19 minus 1. And you get a kind of a long decimal. But if you round it, it's going to be about 0.0069, you could say. And then recursive rule is going to be the previous term, n minus 1, and you're going to multiply by 1/2 times 1/2, or you can put it in parentheses, it doesn't matter. Okay, and then for the next one, this is an arithmetic sequence because you're adding 225 each time, so that is your D common difference. It also happens to be a sub 1, because it's the first term of the sequence. So your explicit rule is a sub n equals the first term, which is 225, plus n minus 1 times the common difference of 225. Okay, you could also simplify that, but for the 19th term, we're going to plug in 19 for n. So a sub 19 equals 225 plus 19 minus 1 times 225. Simplify that and you're going to get 4,275. And then for the recursive rule, you're going to take the previous term, which is a sub n minus 1, and you're going to add 225. Okay? Number 13, determine the sum of the first 15 terms. That means you have to use the sum formula. But you have to first identify what kind of sequence or series it is. So in this case, I am subtracting 2, so that means this is an arithmetic sequence, where a sub 1 equals negative 2, and your common difference is also negative 2. So those are all the things you're going to plug into the sum formula. So it's going to be s sub 15, s sub n, equals, because I'm looking for the 15th term, or the sum of the first 15 terms. So n is 15, so equals 15, parentheses, 2 times negative 2, plus 15 minus 1, times negative 2, divided by 2. When you plug that in and simplify, you're going to get that the sum is negative 240. Okay, so when you're putting this in, it's probably best to go ahead and simplify the things in the parentheses first, so you don't have so many parentheses when you're putting it in your calculator. For number 14, you're multiplying by 2. each time, so that means this is a geometric sequence where a sub 1 equals -2 and your common ratio is 2. So now I'm going to plug it into my formula, s sub 15, because I'm still looking for the 15th term, but now I have to use a formula for a geometric series. So that means I'm going to have to put in a sub 1, which is -2 first, and then times 1 minus the rate of 2 to the 15th power, the nth power, because that's the n that you're looking for, over 1 minus r, and again r is 2 in this case. If I plug that in my calculator, I will get negative 65,534. Number 15. This again is a geometric pattern where your first term is 6,000 and your common ratio is again -1/3, just like one in the beginning. So the formula is going to be s sub 15 equals 6,000, the first term, times 1 minus the rate of -1/3 raised to the nth power, which is 15, over 1 minus the rate of -1/3. Okay, again, plugging all that in your calculator will give you 4,500.000314. For number 16, this is actually an arithmetic where your first term is 55 and your common difference is going to be 6. So you're going to plug that in, s sub 15 equals 15 times 2 times the first term, 55, plus 15 minus 1, n minus 1, times the common difference of 6, all divided by 2. Plug it in your calculator and you get 1,455. Okay, I'm going to do a separate video for all the word problems.